In the last sessions, we have discussed with configuration file and node. And in this session, we are going to discuss with partitioning techniques. And we have seen what mainly the partition sections, partitions play a key role with the node concept. I'll just open one job and we'll see what are the concepts that we have. What are the partitioning techniques we have. Input tab, partitioning tab, in input page, partitioning tab, you can see the list of the partitioning techniques. Partitioning / collecting. Okay. So partitioning, in this tab you can say partitioning, but in this tab we can have a collecting methods. Okay, collecting methods. If you see, we will have less ordered, round robin, sort match. Okay, it varies from stage to stage, but commonly we have partitioning tab, and these are the 8 partitioning techniques that we have. Okay, and in general these are categorized into 2 partitioning techniques. In Datastage there are 2 partitioning techniques like key based partition techniques and keyless partitioning techniques. So first we will see how to define, first of all, which is keyless and what is key based. Key based are how to identify them. Okay, as I am discussing, but practically how to prove that these are like key based and these are like keyless. I'll just categorize them and later I'll show you with a practical concept. Okay, key based partitioning techniques are hash, modulus, range, db2. Keyless partitioning techniques are keyless, round robin, random, entire, round robin, entire, same. And by default partitioning technique is auto. By default partitioning technique is auto. So db2, entire, hash, modulus, random, range, round robin, same. Okay, now how to identify which is a key based partitioning technique and keyless partitioning technique. See, for example, if you are able to view this area, this is disabled, means it's not active. If you go for entire is which type of partitioning technique? Entire is keyless partitioning technique. When you say keyless, see, it is enabled with only perform sort. This area is enabled with perform sort. If I don't select this entire partitioning technique, I have selected and click OK. It will work with this entire partitioning technique. See, this is your symbol of entire partitioning technique. Means like what do we say? This is like link markers. If you enable this, you will get each and every partitioning technique link mark. Okay, this is keyless. Means when you select entire and click OK, it doesn't ask you any key you want to select or anything. It did not ask because it is a keyless. Now I'll choose one of the key based partitioning technique. For example, hash. Hash is my key based partitioning technique. When I select key based hash, see, and try to click OK, it will ask me there must be at least one key selected for the correct partitioning collecting method. So this is the way to confirm whether this partitioning, because today you may view this video, you may understand, but tomorrow if you are in practical and you want to know which partitioning technique is this, and if you have any question to clarify whether it is key based or keyless, this is the way that you can identify. I just select hash employee number and click OK. So this is the one case of key based and keyless partitioning technique. This is what you need to do. Okay, I don't want, and one more thing, how many ways we can remove the duplicates. See, when I say perform sort, for example, I'm selecting entire. Entire is a key based, keyless. Yeah, I want to remove duplicates, department number, say unique. So when you say unique, duplicates will be removed on department number. So this is one way. This is common in every stage. Most of the processing stages will have input page partitioning technique and perform sort option. So if someone asks you how many ways we can perform remove duplicates in data stage, means the first and most important is remove duplicate stage. And next sort stage, allow duplicates option, true or false. And next link level, in every processing stage we can remove the duplicates using perform sort option in input page partitioning tab. Select perform sort and click on unique. Automatically you can select one key column, and based on that key column it will remove the duplicates. Okay, I'll just try to show you how it works. Okay, instead of entire I'll just select same, and same department number unique records. It has to compile, I compile it. So it is taking 14 records. If duplicates are removed, only 3 records should be loaded. See, 3 records got loaded. It was doing on which partitioning and which key column? Department number. So if you remember the class of remove duplicate stage, class of the remove duplicate stage or copy. So remove duplicate stage only if department number, if you do 3 records, and if you do one job, only 5 records will be returned to the target. Correct or not? So I'll just select now the key column as job. So total 5 records. See, 5 records. So this is the one way to remove the duplicates. So multiple ways in transformer also we can do. Not only this option, like with this option even we can do, and again we can use some stage variables and we can do. We'll see that in the next coming session. Okay. So now we'll see how these partitioning techniques will work. How these partitioning techniques will work. How key based. First of all, we'll see keyless partitioning techniques will work. Next we'll go for key based. First I'm taking keyless, which is round robin. So assume that I'm running with 4 nodes. Assume that I'm running job with 4 nodes, and I have
This conference will now be recorded.
Okay, so here I have 12 records and I have 4 nodes. I have 4 nodes. So this is node 1. Okay, so this is node 1, node 2, node 3, node 4. Okay, give me 1 minute. I'll just select in this way. Okay, so this is node 1. This is node 2, node 3 and node 4.
This conference will now be recorded.
So 4 nodes I have. Now when I choose keyless partitioning technique round robin, how the data will flow? How the data will flow, we'll see. So what happens? The first record goes to first node, second record goes to second node, third record goes to third node, and fourth record goes to fourth node. So 1, 2, 3, 4. So it is round robin. Round robin na from first again. So fifth record goes to first node, sixth record goes to second node, seventh record goes to third node, and eighth record goes to fourth node. So here 5, 6, 7, 8. So next ninth again first record node, first node, 10th second node, 11th third node, so 12th. So this is round partitioning, round robin partitioning technique. So this is the way the data flows. So 4 nodes are there, 12 records are there. What will happen? Total 4 nodes will have 3 records. But for 3 records you cannot choose one node, but by default I'm telling you in this way for example. But in real time lakhs of records will be there. So there will be 68 records, 68 node. So 68 nodes architecture, 68 a node or configuration file. In such a way it will work. Okay. So this is your round robin partitioning technique. Round robin partitioning technique. Next, random. So random means this option closing round robin. This just I'll just give control Z. Okay. So it is 1 second. Okay. Okay. So now if random means there is no order. There is no order. It can go anywhere. The first record goes to second node, the second node goes to first node, and third record goes to third node, or fourth record goes to fourth node. There is no order at all. There is no order at all, but it equally splits. 3 records will come here, 3 records will come to node 2, 3 records will come to node 3, 3 records will come to fourth node, but we cannot give the order. That's what random. That's what about the random. That is random partitioning. And entire. Next one is entire. What is meant by entire means the total 12 number of records. The total 12 number of records will go into each node. Each node. Into each node. So 12 records here, 12 records into node 2, 12 records into node 3, 12 records into node 4. Total how many records are created? 48 records are getting created. 48 records are going to create. So what is happening here? Duplicacy. Duplicates are getting created. So this is not a correct partitioning technique that we use. That is the reason entire is used only in one case, in one situation, that is in lookup stage. That is when we are using lookup stage, because in the reference the data get splits into multiple nodes, means the reference data is matching with the primary data in the node case. See, for example, it may happen in this way. For example, only in the reference input link we need to provide. We have to go to lookup stage, stage properties. I'm sorry, not this one. Stage properties, input. You have to choose which is the reference link. Which is reference link you have to choose. DS link 4 is reference link. I'm sorry, again. DS link 4 is the reference link. Here you need to specify entire. So when I say entire, what will happen? Entire, all the records of this lookup reference will go to each and every partitioning. Then the primary data may look up with any node. The lookup records will not mismatch. So there is a chance of lookup failure because of this node concept. Assume that there is node 1, node 2, node 3, node 4, and again for each and every, for the primary also it is node 1, node 2, node 3, node 4. Assume that 1 record here, 2 records here, 3, 4. This is round robin, for example. So, but in a reference data, if all the records, so here 4, 5, 6, here 7, 8, 9, here 1, 2, 3, here 10, 11, 12. So this node 1 is comparing with this node 1, maybe failure, lookup failure. The records get rejected. But if that case, if you use entire partition technique in the reference, 12 records will be in each node. So whatever the node is lookuping with any node, the lookup get success. It will work properly. So in that case only we are going to use entire partitioning technique in the lookup reference link. In the lookup reference link. That is what about entire. And same. What is meant by same? Same partitioning technique. Okay. See, assume that I have a job flow like this. Stage 1, stage 2, stage 3, stage 4. Whatever the stages. This is job, one job. Now you used here round robin. Round robin. And here also you want to use the same thing. If you put round robin again, what will happen? what the records is performed already round robin from the source, again it will perform round robin. Again it will perform round robin. In that case, what records are arranged in a round robin here, the same thing if you want to perform here, then we go for same. Then we perform same and move it into the target. So this is what is same partitioning technique. And perform wise even, see everything here it is, everything is Java code. So if you use round robin, it will go to Java program and it will see the Java functionality, Java program, and it will bring and execute. So here 2 times it should go if I put round robin. So immediately if I put same, what will happen? It will not go to any place, it just pull the records as it is. In which node, which record is there, the same way it will pull to the next level. So that is what same partitioning technique. It improves the performance even. So this is same partitioning technique. So these are key based partitioning techniques. I'm sorry, keyless partitioning techniques. And now we are going to see key based. Key based partitioning techniques. So key based partitioning techniques are hash, and modulus, range. Okay, first I'll tell you about hash. Give me 1 minute. I'll just arrange these things. See, the records can be like this. The records can be like this without any order. Without any order. Without any order. But when you perform hash, the first functionality what will happen is the first functionality what is going to happen? It is going to sort. It is going to sort the data. So it will sort, and what will happen to each node? So first group of records will go to first node. Second group of records will go to second node. Third record groups will go to third node. And if fourth is there, then fourth record goes to fourth node. So this is the way of hash first. That is the reason when you do join, what happened? Automatically it was sorted. Automatically it was sorted. because join is a key stage. I'll tell you. In the same session, we'll discuss. We'll discuss with the key stages and all those also. Okay, so 40th department, if it is there, it will come here. And 50th department, again it goes to first node, round robin again. So this also like a hash partitioning technique will work in this way. Okay, so that is what about hash. And modulus. Modulus also will work like hash. Modulus will work like hash, but modulus will work only on numeric key values. Only on numeric key values. And next partitioning technique, range. Range of values. Range of values means, for example, date of birth. This is one date value. I want the people who have birth dates as from 85 to 95. This is one range. Or else the age people likes 50 to 60. This is one range. So when you are doing lookup, when you are working with lookup, write range map in development debug stages even. So these all are belongings to the range family, like lookup, range lookup, write range map, and range lookup and write range map. So range partitioning technique even. So when you are doing with the date value, certain data values years, database years will be there. I want data from 50 to 60 years of data. So in that case, there are date range values. So in that case, range partitioning technique will work. So each range. Then that splits into each node, like round robin only. First range of people, this this is node 1, second range, third node, fourth node, in such a way. And next DB2. So DB2 means it is only recommended when you are working with the DB2 database. To be frank, there is no particular order we can say in this way it will work, but DB2 partitioning technique will work when you are using DB2 database only. And next, we have last, the auto by default. This is a default partitioning technique. How it will work? Okay, to talk about auto, see, if I am going for lookup, I told you in the lookup preference which partitioning technique you use? Entire. So that is the best one. So when you put auto, automatically it will work like entire only. Automatically it will work like entire only. And when you say copy, it will work round robin. Then auto will work like round robin only. In join stage, hash is best partitioning technique. In join stage, hash is best partitioning technique. If you put auto, it will work hash like hash only. If you go for aggregator, again it is a hash partitioning technique. The best partitioning technique is hash. It will work like hash only if you put auto. Simple, right? So when you are not sure which partitioning technique you want, just to mention as auto, automatically it will take the partitioning technique which is suitable. Then why should we have these many partitioning techniques? Why can't only alone have auto can be there? But what is the thing is auto is performance. Means if you put round robin, what will happen? It will work directly round robin. But when you put auto, first it will work with the 8 partitioning techniques. And after completion of 8 partitioning techniques, it will look which is the best one. So it takes a lot of time if you put auto. But when you don't know which case, in this case, which partitioning technique you want, automatically put auto, it will take accordingly which is the best performance. Okay. And I'm telling you that hash will be sorted in join stage and all. So when you say key column stages, means like sort, you need to select a key column. In filter, you need to select a key column. In copy, you don't need to select any key column. Directly you can do. And some stages are there like lookup key column specification, but hash is not required. Entire is required for a reference link. So like this, when you say key column stages, when you say automatically it will take hash. So hash partitioning, first what does it do? Based on the key column, it will perform sorting. Based on key column, it will perform sorting. So that is the reason when you do join, data will be already data will sort and come the output. So whenever you use hash partitioning, it will work. Okay, I'm back to auto. Auto, why? What is the reason? We don't use auto alone. We have these many means performance. Okay. So, but by default, auto works in round robin partitioning technique. By default, auto will work in round robin partitioning technique. So these are the partitioning techniques that we have, and we are done with the configuration file and the node concept and the partitioning techniques. So again, we'll back to the stages. We'll see. Okay, in the next stage, what we are going to take. So thanks.